You need to build a rocket ship out of a letter. And honestly, most of them are terrible options. Like genuinely catastrophic choices that will end with you spinning through the void while questioning every life decision that led to this moment. The alphabet has 26 letters, and maybe 3 of them won't immediately kill you. We're ranking them from "you died before liftoff" to "this might actually work." So let's start with the absolute worst offender. Number 10. U. U is V's more stable cousin with a flat bottom connecting the 2 vertical sides, which solves the point at the bottom problem, but creates new issues with weight. Now you've got a curved base that's actually wide enough for engines and fuel, but the curve means thrust doesn't go straight up. It goes up and slightly outward, spreading forces along the curved section. You get maybe 85% efficiency, which sounds okay until you're trying to escape gravity, and that missing 15% is the difference between orbit and lawn dart. The 2 vertical sides are still there, creating drag, but at least they're parallel now instead of angled, so air flows around them consistently. Sit in the bottom of the U and you're in a proper cockpit with walls on 3 sides and a roof option if you add a cover. The curved base distributes landing forces evenly, so touchdowns are smoother than anything we've ranked previously. The main problem is that U is heavy. That curve requires material, and material requires fuel to lift, and fuel requires more material to contain. And you're stuck in a weight spiral that makes launch calculations depressed. Still, this is the first letter where you could feasibly survive flight, which puts it firmly in the middle of the pack. Number 9. J. J is a vertical line with a curved hook at the bottom, which gives you a staff with a cup at the end. The curve creates a natural seat that's actually shaped like a seat, which is revolutionary compared to everything ranked lower. You sit in the hook, the vertical section rises above you like a mast, and you can mount engines along the curve where the bend provides structural support. The problem is that J is front-heavy because all the curve is on one side, so the center of gravity is off-axis. Launch this and it wants to tip forward, turning your rocket into a tumbling rod with you trapped in the curl. The vertical section acts like a giant lever arm, magnifying every wobble, so tiny course corrections become wild swings. You need counterweights on the back of the curve, which adds mass, which requires more fuel, which adds more mass. The curve does protect you from wind somewhat, wrapping around you like a shepherd's crook, except the shepherd is physics, and it's dragging you back to Earth. J is usable if you can solve the balance problem, which means it's theoretically functional, but practically frustrating. You could reach space in this thing if everything goes perfectly, and nothing ever goes perfectly. Number 8. C. C is a curved line forming an open circle, which gives you 3/4 of O's problems, but with an escape route. The opening means you can enter and exit the cockpit without climbing over the walls, which is convenient right up until you realize the opening also lets air in during flight. The curve creates a natural seat along the bottom arc, and the walls rise on both sides, providing protection from lateral wind. Mount engines along the outer curve and thrust distributes evenly across the arc, giving you stable acceleration without the spinning problem O had. The missing section creates asymmetry, so you're slightly unbalanced, but it's manageable with proper weight distribution. The real issue is that the opening faces one direction, which means that's your weak point, structurally and aerodynamically. Air rushes into the gap and creates turbulence inside your cockpit, which is like flying in a wind tunnel that hates you specifically. You need a windscreen or cover for the opening, which defeats the purpose of having an opening, but also keeps you from getting sandblasted by atmosphere. C is surprisingly functional if you can close the gap, which makes it a conditional success. It's the first letter where the problems are solvable, instead of fundamental. Number 7. G. G is C with a horizontal bar extending inward from the opening, which sounds like a minor addition, but actually solves several problems. The bar gives you a flat surface to mount controls, reduces the size of the opening while keeping it accessible, and adds structural rigidity to the weak point. Now the gap is partially closed, so less air rushes in, and you've got a dashboard built into the letter. Sit in the curve, rest your hands on the bar, and you're in a proper cockpit with better wind protection than C offered. The bar does add weight to one side, throwing off the balance slightly, but it's concentrated near the center, so the effect is minimal. Engines mount along the outer curve, same as C, but now the bar acts as a brace, preventing the opening from spreading under stress. The only downside is that the bar gets in the way of entry and exit, so you're climbing over it or ducking under it every time you get in. That's a minor annoyance compared to structural failure, so we're calling it a win. G is C with upgrades, which makes it better by default. You could paint NASA on this thing, and only aerospace engineers would know you're lying. Number 6. S is two curves stacked opposite each other, creating a flowing path from top to bottom that looks like someone drew a snake having a nice day. The curves provide wind protection from multiple angles, because no matter which way air comes from, you've got a curve deflecting it. Sit in the lower curve and the upper curve acts as a roof, blocking vertical wind. The flowing shape means air moves around it smoothly instead of hitting hard edges, reducing drag compared to angular letters. The problem is that S has no straight sections, which makes mounting anything a geometric puzzle. Engines need flat surfaces, and S is nothing but curves. So you're custom fabricating every bracket and hoping your welds hold. The two curves create two separate chambers, so you could put fuel in one and cockpit in the other. But the connecting point between curves is narrow and becomes a structural weak point under stress. The flowing design also means the center of gravity shifts depending on fuel levels, so handling changes throughout the flight. S is gorgeous aerodynamically and a nightmare logistically, which puts it in this weird middle ground where it works great until you have to actually build it. Number 5. P is a vertical line with a closed loop at the top, giving you a staff with a bubble attached. The loop creates an enclosed space perfect for a pressurized cockpit, and the vertical section below provides a stable mounting point for engines and fuel tanks. The closed loop means wind can't get inside, so you're protected from all directions once you're sealed in. The circle at the top is small enough to keep weight reasonable, but large enough to fit a human in fetal position, which is not comfortable but is survivable. The vertical section acts like a spine, distributing loads evenly from top to bottom, and the point where loop meets line is actually well supported, because the circle's structure reinforces the connection. The problem is that P is top-heavy. All your livable space is at the highest point, which makes the whole thing want to tip over before launch. You need extensive counterweights at the bottom, turning the lower section into a weighted staff that's mostly ballast. Launch and the heavy top creates pendulum effects during ascent, swinging you gently back and forth in a way that's nauseating, but not immediately fatal. P works despite its proportions, which makes it better than letters with fundamental flaws. You're fighting weight distribution instead of fighting physics, and weight distribution can be solved with engineering. Number 4. B. B is P's overachieving sibling with two loops stacked vertically on a straight line. Now you've got two pressurized chambers, which means you can separate cockpit from fuel storage, or create redundant life support, or just have a bathroom on a different floor. The dual loops distribute weight more evenly than P's single top-heavy bubble, so balance is easier to maintain. The vertical section still acts as a structural spine, but now it's supporting two connection points, which spread stress across more surface area. Each loop is smaller than P's single bubble, which means less internal volume, but also less material needed. So the weight savings almost compensate for having two instead of one. The stacked design creates a tall rocket, which is actually good for stability because tall things are harder to tip than short, wide things. Air flows around both loops, creating smooth aerodynamic profile from bottom to top. The main issue is that the two loops create two separate drag points, so you're pushing two bubbles through the atmosphere instead of one. Still, the benefits outweigh the problems. B is the first letter that feels purpose-built for rocketry, instead of accidentally functional. You could show this to an engineer and they'd nod appreciatively instead of backing away slowly. Number 3. R. R is P with a diagonal leg extending from where the loop meets the vertical line, which adds a third support point and creates a tripod effect. The loop at the top still works as a pressurized cockpit. The vertical section still handles structural loads, and now you've got a diagonal brace preventing lateral movement. The three-point contact with the ground makes launch pad stability perfect, because tripods don't tip. The diagonal leg can house secondary systems like backup power or additional fuel, turning wasted space into useful storage. The loop line leg configuration distributes forces in 3 directions, which means no single point takes all the stress. Launch, and the diagonal acts like a keel, keeping you oriented correctly during ascent. The angle of the leg creates slight asymmetry, so you're not perfectly balanced, but the tripod base compensates for the offset weight. R looks like it's stepping forward, which is accidentally appropriate because this letter actually moves toward being a functional spacecraft. The only downside is that the diagonal leg creates one more surface for air to hit, adding drag in one direction. But the stability gains are worth the aerodynamic cost. R is the first letter where you'd trust your life to it without extensive modifications, which is the benchmark we should have been using all along. Number 2. D. D is a vertical line with a large curve attached to one side, forming a half circle that's fully enclosed and spacious. The curve creates a massive pressurized chamber with actual room to move around, which is luxury compared to P's fetal position requirement. The vertical section acts as a hinge line, keeping everything aligned, and the curve distributes stress evenly because circles are structurally efficient. The flat back section, the vertical line, is perfect for mounting engines in a row, giving you symmetrical thrust along a straight plane. The curved front deflects air smoothly, creating excellent aerodynamic profile with minimal turbulence. Sit inside the curve, and you've got walls on 3 sides, a roof overhead, and enough space to bring snacks. The size means you can fit fuel tanks, life support, controls, and storage without cramming everything into corners. The rounded shape makes pressurization efficient because curved surfaces handle internal pressure better than flat ones. D is heavy because there's a lot of letter here, but it's useful weight, not dead weight. Everything serves a purpose. The only flaw is that the flat back creates some drag, but it's a small price to pay for having the most livable interior we've seen. D is the first letter that feels like a spacecraft instead of a survival challenge. You could live in this thing during flight instead of just enduring it. Number 1. O. Turns out we were wrong about O the first time because we were thinking about it incorrectly. O isn't a donut, it's a tube. Mount engines around the outer circumference pointing down, and suddenly you've got 360 degrees of thrust, creating a perfectly balanced upward force. The circular structure is the strongest possible shape for handling internal pressure, which means you can pressurize the interior to Earth's normal atmosphere without stress fractures. The hollow center becomes a massive cockpit with space to float around in zero gravity, making it the only letter where microgravity is a feature instead of a problem. The symmetry means center of gravity stays centered, regardless of fuel distribution, so handling is consistent throughout the flight. Air flows around the smooth curve with zero turbulence because there are no edges to create vortices. The circle rolls on the ground, sure, but that's what launch cradles are for. Once you're airborne, the rotation becomes gyroscopic stability, turning your rocket into a self-stabilizing spacecraft that resists course deviation. You can enter through a hatch anywhere on the circumference, and the structural integrity doesn't care because every point is equally supported by every other point. O is what happens when geometry and physics agree on something, which is rare enough to be noteworthy. It's the only letter where adding humans improves the design because our weight centers the balance point. This isn't just the best letter for a rocket ship, it's suspiciously good. Like someone designed the alphabet with this exact use case in mind and hit it at the end of the ranking as a reward for paying attention.